Hi, welcome to Petradot, and in this lesson we are going to be talking about list in Java. List is an interface within the Java collection framework that presents an ordered collection of elements, and each element in a list can be accessed with their integer index. Just like um, in our previous lesson where we talked about an array, we say that to get items in an array or to add items in an array, we use the index. So array is index based, and so is list. So the list can be important when you want to, for example, create an application where you're going to be holding a collection of students' record. Let's say you are creating a table that should be holding the names of the students in a particular class. Then the list might come to play at that moment. So list is used to hold is just an interface that's used to hold a collection of items. And the most common concrete classes that implements the list in Java interface collection is the array list and the linked list. Now, array list is just a resizable array implementation. What we mean resizable is, if you can recall when we treated an array, you notice that when you are creating an array, say something like strange names equal to new array of strange, we used to pass the size, say for example 10. At this moment, it is static here. The size here remains the same, whether there is an item added to it or not. It is not resizable, right? If you want to add an 11th item, means you must have to come here to increase the size. So while it is in runtime, it cannot grow on its own nor reduce. But an array list is resizable during runtime. So if, for example, this is the first item in the array, and you want to add another item, at this point, you notice that the length is 4. Any item you add, say 32, will automatically increase the size of the array list, right? And if you remove an item, let's say this 12 here, the array will automatically shrink itself and go back to this size, right? So that is the difference between the array list and the normal array. So to define an array list in Java, you go this way. Either you start with list, just say list, and then with your greater than less than brackets, you enter the type of data it's going to be holding, right? Let's say, for example, we are going to be storing integers. Now, one of the characteristics of an array list, let me state it here before we continue, is that it holds object it's an object storage only, meaning that an array list can only store objects, not primitive data types. When we mean primitive data type is something like int, char, or boolean. Instead, they will this state you must use their corresponding wrapper classes, which is like integer for int. So let's say I want to hold numbers. Instead of using normal int here, it will be showing an error. So you use their object wrappers, which is integer, which represent the same thing. So we can now say list of type integer going to hold nums equal to new array list. And this is how to create an array list in Java. So with this now, you can decide to start adding items to this um, array list, which could be, for example, let's say we want to add a number to this array list, nums dot add say 20, right? So we can now, let's say for example, we want to check the size of this array at this moment. So we'll do system dot out dot println array list size. Then let's concatenate the value, which is nums dot size. So the array list provided us the method. We have a default method for checking the size of the array. So remember that when we treated normal array, To find the length of an array, we'll use dot length, but that of an array list or a list class is using dot size. So let's run this program and see what is going to happen. All right, you can see that the size of this array is 1 because we just added one item. Let's say we'll add another item, nums.add 30. So if we run this again, let's see, it's going to be showing 2. Now, recall that we said here that array elements can be accessed by their integer index. Meaning, if I want to pick the item at a particular point, we'll have to use the index. And most time we are going to be using index to access items in an array. The index starts from 0 by default. So for you to pick the item, the first item in this array list, you have to use index 0. So let's use, for example, let me just copy this. I want to print the first item in the array, item on index 0 is what? So we use dot get. So the list class interface provides us with a method dot get to get the particular item at a particular index. So passing 0 here will give us the item on the first position of the list. So run this program and see. You can see that we'll have 20 here. So if I want to access the second item, I have to be using 1, right? Exactly, and we're having 30. So if you watch here, I didn't specify the size before adding any item. I can add as many items as I want without strictly or specifically stating the size when creating the array list, right? So array list, the list interface is resizable during runtime, right? So it has so many other methods which we are still going to talk about. But then let's talk about the linked list, which is the second concrete classes that implemented the list interface. So, okay, before that, the characteristics of the array list is that the primary advantage of an array list over a traditional array is its dynamic sizing, which we have already talked about. You do not need to specify a fixed size at creation, and it's storage only, which we have also talked about. You can only store objects, not primitive data types like integer, character, or boolean. Then it is an ordered collection, meaning that elements are stored and accessed in the order in which they are inserted. Say, for example, you are inserted 20 first and the next one is 30. That is order. The order is going to remain. It's going to be in that same order, except you bring 30 here first and bring 20 second. Then that will keep the order that way. So it is an ordered collection. Then random access is fast. It offers fast random access to elements, right? So for you to pick items in an array list is always very fast. Now let's compare it to a linked list. Linked list is actually a doubly linked list data structure. So what do we mean by that? It means each node contains 3 parts. That is the data, a reference to the next node, the data, a reference to the next node, and a reference to the previous node. That is thing that made it a doubly linked list. What we mean doubly is that when the item is here, it has 2 links. The first link here at the first side and the second link. So what does it mean? Let's say these are the items in an array or in a list. These are the items in the list. But each item, also called a node, holds the address of the previous node and then the address of the next node, right? But by default, the first item, which is the first node, the address of the previous node is always null because it means that there is no node that is coming before this item, right? But it is holding the address to the next item or the next node, which is telling us that we are now going to the next node 1 here. That is assuming that the address of the next node is node 1, right? So when you come here, you see that it contains an item 2 here, right? And it's telling us that the last item you passed is existing in node 1, in node 0, sorry, right? Which is the address of the previous item, also called node 0. Then it's not telling you that for you to get the next item following me here, following this item 2, you have to access node 2 address, right? Which is the address of the next node you are going to meet, right? So when you come to the item 3, it will tell you that you just left the previous node, which the address is node 2. But for you to access the next node is null because there is no other item following me. That is what it means. So this is exactly how the linked list is structured in the memory. So that's why it's called the doubly linked list, because it contains the address of the previous node and the address of the next node. So for you to define a linked list in Java, you go this way: list. Let's say, for example, we also want to hold integer. List int favorite norms equal to new linked list. There is really no difference in the way you add items and you access items in the linked list. The only difference between the two, that is array list and linked list, is their memory performance, right? So for you to still add items to linked list, you do the same way, which is favorite numbers dot add, just the same thing. Say 55, and favorite numbers dot add 60, right? So for us to print a particular item in a particular index, system.out.println, say linked list at index 1. Let's print the item at index 1, which is favorite numbers dot get 1. So if we run this program, let's see what it's going to show. So you can see that we have 60 because we are accessing index 1 here, right? So it's actually the same thing in the way you add items and access item. And you can as well clear the list. The list class provides us with different methods that you can use to perform action on any type of the list that you have created. That is either linked list or array list. Now, what is their differences? So let's go to the characteristics. First is that it has a dynamic size, just like the normal list, which is it grows or shrinks dynamically at runtime. Then it maintains insertion order. That is the way you have inserted it. It maintains the order that same way, just like the array list. And it allows duplicates too, just like the array list, right? Then it is efficient insertion and deletion. If you want to insert items, it is efficient, right? And is faster compared to an array list. It is faster compared to that. Yes. So now there are different methods. The list class or interface, sorry, has different methods in each store that is created by default. You can use to manipulate the data in any of them, which includes the add we have used, the get, the remove. So let's say, for example, I want to remove the first item. I want to remove this item. So you can use let me do this, copy this first. So linked list remove item at index 0. So after that, let's get the length of the list again. System.out.println linked list size. So we'll now say favorite numbers dot size. So when we remove it, we'll check the size to see what is going to. Okay, we did get here dot remove. Sorry. So we are going to be removing the item at index 0. So let's run this program and see. Okay, we just did linked list remove item at index 0 and we changed the size. It is now 1. You see now, the size has shrinked and become 1. But before, the size used to be 2, though this one is a array list size. But if you check the size before this, you see that the size was 2. Then when we remove the item at index 0, it became 1. So now also, just like other objects in Java, for you to be able to access all the default methods, all you just need to do is call the name of that class you've created or the object, then press your dot, and it will automatically show you the list of the methods you can use to work on that particular object on this array list or linked list. All right. You can test run all these methods on your own end to see how they work, and also check out the Java documentation on the list. If there is any question, drop it on the comment section, and don't forget to like and subscribe. Thank you.